Okay, so this is going to be a quick review of vectors and how to add them together and what a scalar multiple means. So let's start with a vector. A vector has two components and it is typically indicated with brackets. And the two components are the change in x and the change in y, or delta x, delta y. And these two things may seem familiar because that's also how we write slope. The slope is the change in y over the change in x, and so we can take this information and put it into vector format. The way that we graph a vector, let's take the vector 3, 4 as an example. The way that we graph it on a coordinate plane is by simply looking at the change in x and the change in y. So the change in x is over 3. And the change in y is up 4. So we go over 3, up 4, and we graph this vector. And so note that the vector actually starts from 0, 0 and moves to the point 3, 4. The vector is not the point. The vector, rather, is the directed segment from 0, 0 to 3, 4. So let's go ahead and slide here, and we'll talk about a vector that does not originate at the origin. So let's look at the vector from, let's start at the point 2, 3, and we will go to the point 7, 5. So on the coordinate plane, it's very easy to see. Let's see, these two are 2 points. So we'll graph 2, 3 there, and we will graph 7, 5 up here. And so we are looking for the vector from 2, 3 to 7, 5. And so we can simply look at the change in x and the change in y. So the change in x here is from 2 to 7, so that's 5. And this change in y is from 3 to 5, so that is a positive 2. And so this vector here can be written as the vector 5, 2. Now notice that I can also write and draw this vector originating from the origin. If I was to start here at 0, 0 and graph over 5 and up 2 to this point right here, then I would do this vector there. And so the white vector and the blue vector are the same vector. They have the same direction and the same length. One starts at the origin and the other starts at the point 2, 3. Okay, so let's talk a little bit about magnitude. Another word for magnitude is length. And so when I talk about the magnitude of a vector, I'm talking about how long it is. So let's take the vector negative 2, 7. And so again, the way that I plot this is I start at 0, 0, and I plot negative 2 and positive 7. So over 2, up 7, and I draw from beginning to end. And there's my vector, negative 2, 7. Now, if I wanted to find out the length of this vector, I know that I have here 2 and up 7. So this is a 2 by 7 right triangle. And so I can get 2 squared plus 7 squared equals my c squared. So I get the square root of 53 equals c. And that's just basic Pythagorean theorem. You can also use distance formula from the point 0, 0 to the point -2, 7, and that would give you the magnitude or the length of the vector. Okay, let's talk about adding vectors together. So adding vectors has to be done the way we call it. It has to be done adding them tip to tail. So when I look at a vector, I have the tip, which is the head, and the tail, which is the end. And when I look on a coordinate plane here, I have to be able to line up my vectors tip to tail. So let's say that I have the vector 3, 0. So that goes out to the point 3, 0, and it is on the x-axis. Let's also say that I have the vector 2, 4. So I'm going to go out to 2 and up to 4, right about there, and I'm going to draw my vector from the origin there. So now I have my two vectors, 2, 4, and 3, 0. And what I can do is translate vectors, meaning I can pick them up and move them on the coordinate plane. So this vector 2, 4, I can actually pick it up and move it right over here. Now note that it has to have the same direction and the same length as the original vector. But now I've lined up my vector 3, 0 and 2, 4 in what we call tip to tail. So tip to tail right there. And the resulting vector actually would then go from beginning to end. And so the resulting vector is 5, 4. And the way that I do that is I look at my original vectors, 3, 0, and I add the vector 2, 4. And all I simply do is add the x components. 3 plus 2 is 5, and 0 plus 4 is 4. So the resulting vector from beginning to end is 5, 4. The last thing I'd like to talk about in vectors is called scalar multiplication. And what this means is I'm simply multiplying a vector by a constant. So if I were to take the vector -2, 5, I can say that this magnitude here is the square root of 2 squared plus 5 squared, or that is the square root of 29. Now, if I wanted to find a vector that was twice as long as this and in the same direction, I would simply multiply this vector by 2. And distribute in or multiply in the vector to each component, the x component and the y component. So a vector that points in the same direction as -2, 5, but is twice as long would be -4, 10. And that's simply how we do scalar multiples. Another example of that, let's get rid of this example here, would be, let's say we want to find a vector that opposes this direction. So what we do there is we would multiply the vector to -2, 5 by a -1. And then I distribute in my negative. So it becomes 2, negative 5. And now this is a vector of the same length, but in the negative or opposite direction. So scalar multiples are really that easy. We just distribute in the multiple at the front of the bracket into each component of the vector.